The electronics market is going digital. This requires a technology upgrade for almost all of us. Hewlett Packard is going to solve the measurement problems for the digital customer, so let us take a few moments of your time to tell you about our plans. Applications for electronic instruments are becoming more and more digital every day. Just look around Hewlett Packard. Look in the stock bin. It's full of dips and flat packs. Loveland doesn't build oscillators anymore. They build digital synthesizers. San Diego builds digital plotters. Colorado Springs builds digital control circuitry into an oscilloscope. On a higher level, AMD marries the instrument to the computer. We even have whole divisions devoted to digital equipment, making mini computers and calculators. Look at the semiconductor industry. The big companies like Motorola, Fairchild, TI, all have digital product lines. Look at the growth of small companies in the digital areas. People like Mostek, Harris, Intel. Pick up any trade magazine. See courses on MOS basics. Titles like Makers Debate ECL Compatibility. Improve fault finding with automatic functional testers. The new mini computers, faster, sophisticated, and a choice of MOS or bipolar memories. Look at the whole digital industry. Big computers, mini computers, peripherals, terminals, process and control equipment, and calculators. All these new things must have created some new measurement problems. These problems offer tremendous growth opportunities for Hewlett Packard. Electrical measurements of voltage and time are now described as clock phasing problems. Time must be measured very accurately over several different signal paths in the computer. Measurements are made on timing margins to look for race conditions. That is, a condition where two supposedly coincident signals arrive at different times, producing a glitch or an erroneous output of the gate. Glitch analysis, the location and detection of random spikes in the system, is now important. On a higher level, functional measurements become important for the system. An overview of the system performance can be seen with things like flowcharts and state maps. Functional presentation of the states and the flow of the logic can be done with either ones and zeros on a CRT or LED display. Troubleshooting to the component level is necessary to determine which specific gate is bad or not operating, or which specific dual inline package must be replaced. On a third level, statistical or computational parameters can be used to describe digital applications. Those people concerned with transmitting digits measure things like bit error rate and block error rate, the number of errors generated per given block of data transmitted. Those people involved with software or algorithms need to measure the efficiency of their software, that is, the percentage of time spent in different subroutine loops. They must know the effectiveness of how they're utilizing the core memory. In troubleshooting, for example, we can measure the number of transitions in a given time period at a given circuit node. Hewlett Packard will continue to improve its solutions to these measurement problems and will create new solutions for the new problems that develop. In electrical analysis, oscilloscopes like the 1710A, 150 MHz bandwidth, and the 183A, 250 MHz bandwidth, provide the timing accuracies necessary for the faster circuitry. Capturing single-shot glitches is an important problem solved with storage scopes like the 184A. New products are aimed at making these electrical measurements better. Instruments like the 1834A, 4-channel, 200 MHz oscilloscope, or a multi-channel digital oscilloscope aimed at locating and time referencing glitches. Functional measurements are provided on components with logic probes and logic clips. Dynamic analysis can be performed with a multi-channel scope like the 1804A, 50 MHz bandwidth and 4 input channels. New products, like our family of logic analyzers, are aimed specifically at functional measurements. The 1601A, 12-channel single clock system for 10 MHz operation. The 5000A, 2-channel, lightweight portable unit with an LED display. Statistical measurements have been made with PRBS generators and counters in the past. New products like the 1645A digital error detector and the 3760 and 3761 PCM link error detectors will improve our statistical capability. Digital stimulus is also provided. Pulse generators and data generators like the 1925A and 8006A. Pseudo-random sequence generators like the 1930A. New products are being developed like the 8016A multi-channel data generator. All of these products are aimed at improving our penetration in these market areas. To accomplish the objectives of dominating this new measurement area requires extensive training and support for all of us. We must increase our understanding of the technology. As a corporation, we are planning to provide this necessary support. Tutorial training on integrated circuit basics has already been done. Videotapes will be provided on the basics of digital circuit design, on the characteristics of digital devices, the types of measurements that need to be made, and specialized market applications, like data communications. Textbooks will also be published to document these extensive training sessions. Specific instrument training must also be upgraded. Field training manuals must be provided with information to make it easier to communicate with customers in specific market areas. New product training will be provided with hands-on time and actual demos of the system performance. Key account training can be done either at central offices in the field or at the factory, tailored to specific customer types. This support must continue throughout the life of these new products. Exciting changes are taking place. This requires effort from all of us to increase our understanding of digital technology. Together, we can make Hewlett Packard the digital measurement leader. Thanks for your attention.